Waco, Texas is a place in Texas.
What's
Wait.
Waco?
Wait, where's Kramer? Yeah, we got him home.
He just doesn't want to come.
Where is he? Bed till 1.
Oh, you're in my bag.
Wait,
you
why?
go to bed till 1?
Because we were driving
So let
home,
me take this,
like from the audition.
You didn't sleep in the car?
No, they partied in the car.
So that's a
Party
C.
or not, they have it at like 12:30, but I don't know. I went to bed at 10:30.
I could not fall asleep. I didn't get home until 11:30, which was.
Did
That's
any
like
of you
my
watch
least favorite aspect of math.
Well,
my mom can't go.
Ish.
I'm gonna go.
Wait, what was the question?
I said, did any of you
Yeah,
watch?
As long as it-
Yes.
Stupid versions.
No, that was G.
Are we live?
Who
Yes.
won?
Yay.
Are we live?
By 3.
I'm really bad.
I didn't even know.
Like 49ers should have won. I
The
was
sad
the
thing is,
49ers.
my
I conflicted with myself because I was my dad lives in Baltimore and that my dad's from Baltimore. Okay, but I'm going to San Francisco this summer, so I was like, you know what? I'm gonna root for the Ravens.
Okay, I did too.
So and they lost. I was like,
You can't deny though that like
109
yards in 11 seconds
is crazy.
is a genius play. I mean,
How's it going?
They were just like zooming across the floor. Did you watch the Super Bowl?
Sparingly. Being given what happened yesterday, I'll explain very quickly for those of you who weren't there. Funny may not be the right word, but in retrospect, maybe people laugh about it one day.
I'm just kidding.
Saturday,
I had nightmares.
yeah, which I
It was terrifying.
Saturday, Eric and I are driving, and the water temperature on the car is going like to H, like the bread, and there's steam coming from under the hood, and you're like, that's not good, right? Because there's supposed to be a cooling system that keeps the engine from getting too hot. The engine gets hot because there's little tiny explosions in there when the gasoline is burning. You gotta keep it cool. Well, if you don't have any coolant in your car, it doesn't stay cool. So, we had to put coolant in the car. Now, to put coolant in the car, you have to open this thing that says do not open, blah, blah, blah. But, so when you do, boiling coolant comes flying out, and there's a big pile of steam like rising up, and everybody at the gas station is looking at you like, what is this idiot doing? Meanwhile, there's like superheated coolant water like bubbling. It could have bubbled on you, but if you just, I had a towel, well, it wasn't a towel, it was actually one of those bags that you take to like Kroger to save packages there. And I was opening it, and like, little bit, and then when it started gurgling, like just running away. It was way up. Long story short, there's a leak in one of the coolant pipes, and that's why the coolant was running low, because we filled it up, and then 3 hours of driving later, it's doing the exact same thing. And it's like, that's not, like, the coolant should not run out every 3 hours of driving, right? So Sears was nice enough to say, hey, like, if you can't find the leak yourself, you can bring it down to us and we'll find the leak for you. So they did. And there's a little piece inside the car that's like the size of a straw at Wendy's. And it had a little pinhole leak, and there's coolant spewing out of it when the car's running. And the guy's like, all you gotta do is replace this part. Go down to AutoZone, it's like $2. It's like just pliers, put the new tube in, everything will be fine. So, take the car, drive it away to AutoZone. On our way to AutoZone, we're driving down Clinton Street. 50 miles an hour, cars all around us. The hood comes up to the windshield, and all you see is green. Except for like this little 1-inch region underneath. The hood is arced just enough for you to see in the event that someone doesn't properly latch your hood, like the people at Sears did.
Oh god.
The hood comes up, windshield cracked. So cracked that you can feel the cracks from the inside. So if so much as a pebble from a semi, like on the highway hit the windshield, shatter. Glass shatter everywhere. I mean, it'd be in our eyes, it'd be in our ears and mouth, it would be everywhere. And we'd be like stitched up like crazy, both Eric and I. 2, when the hood comes up, it completely unhinged, and it bent, like the hood is normally contoured like this, right? But see, the windshield is contoured like that. So when the hood pops up, the windshield the hood that's normally contoured, right? Here's the normal hood contour. But when it comes flying up at 45 miles an hour, the hood contours back like that. So when you try to take the hood and close it again, because here's where the latch is, it looks something like this. And you're like, how am I going to latch that? So the way that you do that is you tell your wife who's inside the car, honey, pull the hood latch so that the little spring in there has tension released. I'm going to stand on top of the car, so here's me. And I should put myself, I was jumping into the air so that whenever I would land, I would bend the metal back. Now, there are two hood latches whenever you latch your car. There's one that comes over the top like this, and there's another one that is like the jaws of life that comes below and comes in underneath. So the top one is there as a safety mechanism if the bottom one ever fails. You have two hood latches so that engineers call that a safety factor, like just in case something goes wrong, then the car's still okay and you don't have a hood in your, well, you don't, anyways, we got the thing to latch. And then we had to drive back to Sears, and Sears was saying that it was not our fault. And it's like, oh, well, hold on a second. Like that hood has been closed a number of times, and every time it's ever been closed, it's never popped up. You close it, and it pops up. Put those pieces together. And the manager got mad at me whenever I said
You kept telling him to calm down. And
he's like, I saw him close it and latch it, and I was like,
Really, you don't know what you're talking
Yeah.
I wasn't
looked
even there.
Right at the guy.
yeah, let's
I looked right at the guy and said, "You're a liar." I said, "I was in the garage. You were not in the garage. So don't tell me you were in the garage. You're lying." And he said, "I wasn't in the garage. I'm sorry." And it's like, you're a manager at Sears Auto. I should pimp slap you.
And the first two things out of his mouth to me, were lies. Like what? I mean.
Then he told us, he said, "Oh, drive down the street and go to our insurance company and this, that, and the other."
It's like,
And if I show you guys pictures, if we get time, because I have them on my phone, I said, "So you're willing to let us drive down, 5 miles, 10 miles, in the event that the hood could pop back up again and chance that we both die, you want to be responsible for that?" And as soon as I said that, he was like, "Let me make a call."
the tail between
like-
his legs, just running away like.
Crazy lady. Yeah,
No,
seriously.
not a crazy lady.
Seriously.
No,
She
she
makes
was
a
a
good
smart
point,
lady.
because when that guy says, "No, good riddance, go on your way," then that's a him problem if we get in trouble. And trouble could be death. And I would prefer not to die. Like I have life goals of achieving like high age marks above 65 years old. Right? I don't plan on, like, I could die before I was 30 this weekend. That would have been awful.
Yeah, but the fact that he
I
thought that you
know, it
guys
was
would
messed
buy
up.
The fact that we won.
that he thought you guys would buy that.
And then he's like, "Sir, don't get upset." And it's like, okay, wait a second. This is
I know.
my car.
I know.
Like my wife's car is now probably totaled because you didn't close a hood latch. You need, like, if you just lift up the hood and drop it, like third grader style, it latches both. Like all you have to, like, what? And, whatever. They were nice people because they, like, for free found us this little leak, and we were really happy because it's like
But
this
we're
tiny
gonna
little pipe.
total your car.
Yeah, but yeah.
You know, you almost
Yeah.
died, but we helped you. so-
Yeah,
It's like,
thanks
here,
a lot.
like, here's a piece of candy.
I told that
Your house is
guy.
burning down.
He did give me a piece of candy too.
Did he really?
And
did.
I ate that dang candy
He tried
too.
to sweeten us up.
And when he got upset and said, basically you guys need to leave, I said, one of three things are gonna happen here. I'm gonna call the police.
Uh-huh.
I'm gonna call the police and hire an attorney, or you're gonna give me a rent-a-car, take your pick. Whichever one you want.
She's
Oh,
good.
snap.
She's good.
Oh, snap.
You should see this girl in action. It's
I would have loved to.
That's
No,
Is
just
that
like
the car? Didn't you say you just sold your car?
now the clown car has been sold. The clown car. Remember,
Pepsi
I
one
may have
can.
I told you how the alternator was going bad, so when I was sitting at a light, I had to put it in brake and rev. And I kept the car. When I took the alternator to AutoZone to get tested, the guy said, These numbers are 100 times out of what their normal range is supposed to be.
Oh my god.
It was the variance in voltage that the alternator is supposed to produce is supposed to be
Sorry.
it's supposed to be 0.015 volts. That's normal, and I was at 1.5, so I was off by 1,000 times. And he was like, "I've never seen one that's bad." And I actually quite kind of felt accomplished because I was like, I pushed that thing to the limit. To the limit. And that guy in AutoZone has never seen anything like it. So I sold it to a friend of mine who can fix cars, and he's gonna fix the car up, and then he's gonna resell it to a friend of his, and everybody wins. Cause we get a little, but then the thing that sucks about it is having just sold that car, and do you guys remember like my old sports car, like the nice green, like, yeah, that car is getting worked on right now, and it's about to be fixed in the next month. And that car was just towed to a shop in the past week. So last week, we tow my Lexus to get work done. We sell my Tercel. And then we have this little leak in our Honda, and we're like, oh no. We find the leak, and we're like, oh yay. And then, boom.
Yeah, exactly.
And we're driving my mother's car. Like,
Bye.
yeah, because the manager at Sears, who's actually not a manager, because the manager that they had before, they just fired, so technically he hasn't been assigned a manager yet. So he doesn't have a credit card to be able to make executive decisions, said, I can 95% guarantee you that they'll pay for your rent-a-car, but I can't 100% guarantee you. And it was like,
That's
No.
not a number I wanna
yeah,
work with.
yeah, I wanna work with, and Erica, to her credit, twice pressed him on the issue. He's like, because he said, I am practically certain that they're gonna pay for the rent-a-car. And Eric was like, are you 100% sure? He's like, I'm practically certain. Are you 100% sure? 90 to 95%. Sorry. We're driving our car home, and we better not die, because if we do, I'm gonna be mad, and you're gonna be mad too. But yeah, so we drove home like gently, like every pothole we went over, because the only thing holding the hood was just that one weak little thing. And I'm not kidding you, if you go to the car and you lean down and you push with the pressure of an 18-month-old, that hood pops up. And it's like, it's terrifying.
That sounds awful.
It's terrifying. So moral of the story, we're okay.
Don't go.
Don't go to
Don't go to
Sears.
Sears Auto, very good. You guys are picking up a good moral of
It's
the
really
story.
sad though, because they sound like they're as rude and like when my mom interviewed me, they were just exactly as rude. They should have been like, that's horrible.
Yeah, it's bad.
You know, but we did hear, Holly, that like Sears are going out of
The
business.
Sears Auto Center, yeah, they're going to
Yeah,
business.
so they probably
Makes
just
sense.
don't even care.
So,
Yeah, exactly.
Because like imagine like if you knew that like the carpet inside your house was going to be replaced in 2 months, you're not gonna keep it clean. Like, oh, well, there's a spill, oh, no big deal. Like if you knew carpet was coming in, it's kind of the
Yeah.
same way with Sears Auto. Like if you know that you're going under, like who cares? We'll just lie to our employees from our managers, and or lie to our customers, and not close hood latches, and then not take liability for it, and come on.
Almost kill people.
But yeah, right, yeah.
Oh my God,
It's a
if he would've killed me,
And
I would've came back.
Haunted him for the rest
And
of his life.
I would've, he
It would've
would've
ended
wanna
poorly.
jumped off a bridge. Cause I would
you would have,
be
you would have,
hovering over his body when he's sleeping, you know.
yeah, and he would have jumped, he would have had no choice.
Yep, he would've been a jumper.
You would
Yeah,
have you
that's-
probably would have pushed him.
No push, no push, it's all on him.
Solid.
It's all on him, he voluntarily chose to jump. Let's be clear.
That's horrible.
The part about the jumping was not.
No, not that part, the story.
He would voluntarily jump.
It is.
That's horrible.
Okay, so let's summarize, and let's get a couple examples, and we can then put to rest like our understanding of this chapter, which is good. Okay, so number one, pressure and volume, inversely proportional. As one goes up, the other goes down. You can think of, one way to think of this is squeeze a balloon. Squeeze a balloon, it gets smaller. You increase the pressure, you decrease the volume. And when you have things that are in direct proportion, That means that the multiplied product is constant. We also have what's called Charles' law. I don't know if that was his last name or his first name, but it's, you know, attributed to Mr. Charles. Volume and temperature. Think about this. If you're keeping pressure and number of particles constant, as the temperature increases, the balloon's gonna get bigger. Remember that picture we saw of the balloon dipped in liquid nitrogen? When it heated up, whoop, got bigger, right? That's the universal sound for get bigger. When there's direct proportion, when temperature goes up, volume goes up, remember that the divided result is constant. You can combine those two together and get P1 V1 over T1 equals P2 V2 over T2. I'll tell you right now, these are the three that you will see. These are the three big dogs when it comes to the one case and the other case. These are the three that you'll see. Now, sometimes we talk about gases in only one state, and we're not comparing two states. We're only talking about one particular sample of gas, and we want to find out something about it. In that case, we use Pervner. And I have to put a note here under Pervner, because let's remember what R is. R is 0.0821 liters times atmospheres over Kelvin times mole. I put those units up there every time to hammer it into your head that the pressure needs to be in atmospheres. 1 atmosphere, 760 torr. The volume needs to be in liters. The N needs to be in moles, and temperature in Kelvin. Those are pretty familiar. I should also make a note up here. The temperature has to always be in Kelvin. As Kramer would say, because if it wasn't, that's not right. And as we know, if you put temperature in a unit other than Kelvin, you could have a 0 in the denominator, and that is not kosher. Mathematically, that is against the rules. Okay, bless you. Another fact that we picked up was, at STP, standard temperature and pressure, not to be confused with the mid-90s rock band, Stone Temple Pilots.
Every time you say it, I think,
What?
you guys have heard of
You
Stone Temple Pilots?
If you haven't, go home, YouTube, you can see the music that Eric and I grew up with.
You're making it seem like you're old.
We're not old, we just have a larger knowledge base of music than
No,
they do.
you're, I'm not old.
I would argue with that.
No. You're old, I'm not.
Okay. And I'm comfortable with that because in a few days, like the 10th digit of my age will be one higher than yours, and that's significant.
Yeah.
Okay. So, we used Pervner, and what we found out is when you're at STP, and you have 1 mole of any gas, it's 22.4 liters of volume. How cool is that? Pretty dang cool, because that works for every gas. Every gas. Now, why? Why does this work for every gas? All these things work for every gas. Because generally speaking, gases act ideally. I'm going to stop using the word regular because technically it's called the ideal gas law. Recall, at the beginning of your notes in chapter 10, there were 3 principles behind the ideal gas theory. Know those. Know those. I think one of them was that all matter is made of particles. I think one was that the particles are in perpetual motion. And I think the other was that when the particles collide, no energy is lost. I think that's it. So you put those 3 things together, and then we are good to go. So that's why this works for every gas. We idealize the situation, and all of these beautiful things come. Now, another beautiful thing that can happen, well, it depends on your definition of beauty. To me, it's scientifically beautiful. Here's an example. 2C8H18 plus 25O2 yields 16CO2 plus 18H2O. When you get equations in the future, they'll be balanced. And in addition, because gases work so ideally, you will often, especially on this test, every equation that you get, you will get more information than just the basics. Following every compound, following every element, you'll get something that will tell you its state. G for gas, L for liquid, and S for solid. If it says G for gas, you say hooray, because that means you can follow these simple principles. 25O2, also a gas. Yields 16 CO2, also a gas. Plus 18 H2O, that, my friends, is a liquid. So the gases are nice because we can start setting up ratios. PS, C8H18, it's called octane. Ever heard that word before? Where? Car? Gas pump? It says like 89 octane, 93 octane, 90 whatever octane. This is the reaction that happens inside the engine of your car. 2 molecules of octane mixed with 25 molecules of oxygen to produce 16 particles of carbon dioxide. I emphasize that because that's a lot of carbon dioxide from 2 stinking octane particles. And a little bit of water vapor. The water vapor we're not really concerned about, but the carbon dioxide we are, because carbon dioxide is like a gas blanket covering the atmosphere, traps heat, raises the Earth's temperature. So more combustion, more CO2. You guys know that though, but aside from the reality of that, let me ask a question that relates to this. And let me ask a question like this. If, let's say, 10 moles of C8H18 were burned, how many moles of H2O were formed? Notice this is a question about moles. Notice moles is about quantity, and quantity only relates to the numbers in front. So when we ask a question about moles, this is a question like we could have seen back in previous days. Now, we know, I'm going to write up here under the equation, we have 10 moles of carbon, well, of octane, C8H18. The question is, how many moles of H2O do we form? Well, we should be able to set up a ratio. A ratio between C8H18 and H2O. What's the ratio between those two things that we're discussing in this problem? C8H18 over H2O is? C8H18 has a coefficient of 2. H2O has a coefficient of 18. Now, we start plugging in what we know to find out what we don't know. We didn't know something about water, but we did know something about this C8H18. We knew we had 10 moles of it. So there we go, we can plug in. Cross multiply. 2 H2Os is 180. Therefore, the H2Os are 90. 90 watts. What were we dealing in here? Moles. 90 moles of water. Does that make sense? Does it make sense that 10 moles of octane makes 90 moles of water? Look at the numbers. Does it make sense? 2 octanes to 18 waters, that's 9 times as many waters. So 10 moles, 9 times as many moles. Kosher? Mm-hmm. Good, let's do one more. If 10 liters of oxygen was used, how many liters of CO2 were formed? Fundamental difference between problem A and problem B. Fundamental difference. In part A, we talked about moles. That relates strictly to quantity, strictly to number. When you think about mole, that relates strictly to number. In B, we're talking about liters. That relates strictly to volume, which relates strictly to gases. So the thing we have to realize when we have liters is we have to make sure we're dealing in gases. 10 liters of oxygen, how many liters of CO2? So there's something told to us about oxygen, something coming with CO2. Both gases? Yes, then we can proceed. We have to make sure that they're both gases though, or else we can't answer questions about liters. So here we go, what's the relationship between the oxygen and the CO2? O2 to CO2 is a ratio of? Perfect. Now which one do we know? And we know O2 is 10, so we plug in. And we get 25 times CO2 equals 160. And then we may need a calculator to divide that out nicely, but of course, when the test comes around, you'll be able to use a calculator. Because, well, can that be done? No, that's not going to come out clean. That's going to be like 6.4. Is that right?
Yep. Jeez.
Dang, right? Who said this guy couldn't do math, right?
We don't think it's
I'm talking to the manager at Sears right now.
Don't get me started.
That was to him. I hope he heard it. He's probably walking down the hall and he just got like a chill. Okay, so again, fundamental difference. When we deal with moles, doesn't matter. Moles are related to numbers, and the numbers are all what's in front. When it relates to liters, we're dealing with gases, and we have to make sure that both of the things that we're dealing with are gases. If both of them weren't gases, you'd have to say, well, sorry, I can't answer the question. Because if this said, instead of CO2, if this said H2O, you can't answer the question. Because that's a liquid, and liquids aren't ideal. God, if you ever get into physics classes where you deal with fluid, this is like 300 junior level engineering and physics, and it is, it's really hard stuff. You can hear me. Can you hear me? Like, it hurts to think about. But gases, so nice. Gases are just ideal. Every time you fart, you can always just think of this and take that sauce.
Do you think they were asked a question? Feeling like.
I don't think I'll be that mean. But I mean, I could ask. Here's how I could phrase the question. I could say, if this question was asked, why couldn't you answer it? I can say a question like that, and you'd be like, I can't answer it because H2O is not a gas, and then I can't relate in liters. I can talk in moles all day because moles is numbers, and numbers are there. But when I start talking in liters, I'm talking gases. And when I'm talking gases, I need to make sure I'm dealing with gases. You can measure liquids in liters, but liquids are not ideal. So when it comes to the solids, the liquids, and the gases, not ideal, yes. Ideal. And the solids and the liquids, no, not ideal. I majored for a year and a half at Michigan State in material science, which was basically chemical engineering with solid objects. Not ideal. You have to go to school for 4 years to learn about it. When you deal with gases, it's like high school stuff. Gases are nice. Let me throw you a few questions to work on, so that you have something to base steel and chemistry assignment. Chemistry one. Just one. Or the whole stack is fine too. Yeah, thank you, love you. Okay. Oh shoot. Okay, so, here we go. From page 236 in the problems. Take a look at 2. Take a look at 7. Take a look at 9. Take a look at 13. On page. Let's just leave it at that. Let's leave it at that. This will be due tomorrow. Tomorrow. I'll see you tomorrow. It's only a day away. Chem test